Radioactive decay happens inside the nucleus of isotopes. The nucleus is often unstable and wants to give off parts of itself. It gives off particles and waves. The waves are energy from the nucleus changing, and we call these waves gamma radiation. Let's take a look at each form of radiation decay. Alpha decay happens inside a radioactive nucleus. When the nucleus is unstable, it wants to give off part of itself. Alpha particles are a helium nucleus. They have 2 protons and 2 neutrons. Gamma radiation is also given off by the transfers that happen inside the nucleus. Let's take a look at beta minus decay. Beta minus decay also happens inside the nucleus. When the nucleus becomes unstable, a proton changes into a neutron and an electron. The electron is released, and so is gamma radiation. Electrons have a mass of 0 and a charge of -1. Let's take a look at beta plus decay. Beta plus decay also happens inside the nucleus, but this time when the nucleus becomes unstable, a proton changes into a neutron and a positron. The positron is released along with the gamma radiation. Positrons have a charge of +1 and a mass of 0. Let's take a look at neutron decay. Again, neutron decay happens inside the nucleus, but this time when it becomes unstable, a neutron is released along with the gamma radiation. Neutrons have a mass of 1 and there is no charge associated with a neutron. Part of understanding radioactive decay is understanding decay equations, so we need to look at those as well. We'll start with alpha decay. Here we have the isotope of radium. It's going to give off alpha particles. So we can write the equation like this. As the decay happens, the products afterwards are helium, and that's the alpha particle, plus a new element, which is radon. But why has the element changed? Well, it's all down to the atomic number. Let's see what numbers changed. Well, alpha particle has a mass of 4 and an atomic number of 2. Because the radium gave off the alpha particle, it's now lost 2 protons and 2 neutrons. So the new element, radon, has a decrease in its mass number by 4 and a decrease in its atomic number by 2. When an atomic number changes, the element changes. To summarise, alpha decay, the mass decreases by 4 and the atomic number by 2. Let's take a look at beta decay. This iodine isotope is going to give off beta minus radiation. As it does that, we'll take a look at the products. An electron is released because remember, a neutron has changed into a proton and an electron, and the electron is released. Because the neutron changed into a proton, that means we have to add a proton onto the new element that's been formed. So after the iodine has decayed, it's become a new element, xenon. The mass number hasn't changed because there are still the same amount of particles in the nucleus. To summarise, in beta minus decay, the mass stays the same and the atomic number increases by 1. Let's take a look at beta plus decay. Let's take a look at our starting isotope, which is potassium. Potassium has an atomic number of 19. When it releases beta plus radiation, it releases a positron because a proton has changed into a neutron. Because the proton has changed into a neutron, the atomic number of the new element has decreased by 1. So we can see potassium has changed to argon. The mass number stays the same because there are the same amount of particles in the nucleus. To summarise, in beta plus decay, the mass stays the same and the atomic number decreases by 1. Now the final radiation decay is neutron decay. Here we have an isotope of helium-5. It's releasing neutrons as it decays. So the products would be 1 neutron plus helium still. Because a neutron has been released and no protons have, therefore the atomic number stays the same. And remember, atomic numbers define the element. To summarise, in neutron decay, the mass decreases by 1 and the atomic number stays the same.